Separating liquid/liquid mixtures. Separating funnel, for immiscible liquids. Immiscible liquids do not mix together. Like oil and water. If they are put in one container, the denser liquid will settle at the bottom and the lighter one will go above it. To separate an oil and water mixture, we pour the mixture into the separating funnel. The water is denser than oil, it settles below it. The tap is open to let the water flow into the beaker. The tap is closed when all the water is poured, the beaker is replaced by an empty one and the oil is now poured. Fractional distillation, for miscible liquids. Fractional distillation is a method of separating a mixture of two or more liquids provided that they have different boiling points. The apparatus is set as in the diagram below. When the heat is turned on, the vapor of all the liquids rises. The liquid with the lowest boiling point goes all the way through the glass beads and into the condenser and out on the other side as liquid. The temperature is constant during this. The liquids with the higher boiling points condense on the glass beads. When all of the liquid with the lowest boiling point have evaporated and collected, the temperature starts rising again. The liquid with the second lowest boiling point evaporates now, and gets collected on the other side. And so on. The glass beads are to provide a cool large surface area for condensation. Fractional distillation of crude oil. Crude oil is a mixture of hydrocarbons. It is the major source of fuel. It is refined and separated into several very useful fractions by fractional distillation in a fractionating tower. The higher the fraction is obtained in the fractionating tower, the lower its boiling point. Fuel is a substance that releases energy, etc., coal, natural gas, ethanol. Lubricant is a substance that reduces friction between two surfaces. Hydrocarbons are organic compounds containing carbon and hydrogen only. Different hydrocarbons are collected at different levels according to their boiling points. The higher they are collected, the lower their boiling point. Chromatography. Chromatography is a process used to separate and identify two or more substances from a mixture. This method depends on the solubility of the tested substances. Chromatography is also used to find out the number of components in a drink, for example. Let's say we want to find the number of colored dyes present in black ink. First, we get a piece of filter paper or chromatography paper. We draw a line, in pencil, at the bottom of the paper. This line is called the baseline, and the reason it is drawn in pencil is because pencil is insoluble, so it won't interfere with the solubility of the ink. Then we place a spot of the black ink on the baseline. The chromatography paper is now put with its bottom soaked in a suitable solvent, which is in our case water. The chromatography paper is going to absorb the solvent, which moves upwards. When the solvent reaches the bar line, the spot of black ink will dissolve in it. The solvent will keep moving upwards, taking with it the black ink. The more soluble the contents of the ink, the higher it will move until it can't anymore. Sometimes the substance we are testing is in solid form. In this case, we have to crush and dissolve it in water and filter it. We then take the filtrate and evaporate some of it water to get the most concentrated sample. Then we are ready to do the experiment. When dealing with ethanol in concentrating the sample, we have to heat it in a water bath because it is flammable. And when we use it as solvent in chromatography, it has to be preformed in a covered beaker because ethanol is volatile. The solvent front is the furthest distance traveled by the solvent. Sometimes, the sample is separated into colorless spots. In this case, the chromatography paper is sprayed with a locating agent that locates the spots. The number of spots indicates the number of components in the sample. To identify the substances which were formed when the sample was separated, we measure what's called the RF value. The RF value is the rate of the distance traveled by the solute, the spot, to the distance traveled by the solvent line. It's calculated by measuring the distance traveled by the spot, distance 1, from the baseline, measuring the distance from the baseline to the solvent front, distance 2, and dividing distance 1 by distance 2. This value is always less than 1 because the distance traveled by the solvent is always larger than the distance traveled by the spot. Each substance has a different R. Chromatography can be used to test purity of substances. If a substance gives only one spot, it means it is pure because it contains one substance. If two spots have the same RF value, they are made of the same substance.